My name is Morgan Gifford, and I am the STEM Education Manager for the National Atomic Testing Museum. On behalf of the museum staff and the Nevada Test Site Historical Foundation, I would like to welcome you all to today's distinguished lecture featuring Mr. Stephen Curtis. During his presentation, Mr. Curtis will discuss the modern state of energy production and delivery in the United States and the implications of Nevada becoming a recycle center for used nuclear fuel. Mr. Curtis will be happy to answer audience questions following his talk. So if you do have a question for him, please hold it until the end and wait for a staff member or volunteer to bring you a microphone. This will allow everyone attending remotely to hear your question. And for those of you watching remotely, please write your questions in the Zoom chat box so that we can have Mr. Curtis answer that question for you. It's now my pleasure to tell you more about Mr. Curtis. Mr. Curtis was a technical team leader for the Nuclear Emergency Support Team and Consequence Management technical teams in Nevada for 13 years. He spent time at the University of Nevada, Las Vegas and Desert Research Institute as a part-time development officer for national security programs. Mr. Curtis is a consultant for the Readiness Resource Group in national security, was an active duty Army officer, and a company commander in the Army National Guard. He currently lives in Minnesota and promotes recycling of used nuclear fuel in fast reactors as a primary method to bring clean domestic baseload and efficient electricity to customers in the United States. Now, please join me in welcoming Mr. Stephen Curtis.
Well, thank you. We're changing the face of our museum, and I'm very proud to have seen you come on board, and thank you for that introduction. Right. So I've lived here in Nevada for 38 years, and I moved. Right now I live in the great Midwest in Minnesota, and it's a lot more calm. As far as I'm concerned, to live back there is a lot less hectic than Las Vegas, and that's why I chose to do that. But the whole purpose of this education today is probably to tell you something you haven't heard before, something different from what you hear in the regular media or on the regular discussion points. And so that's why I want to leave some time for questions at the end. The whole purpose of this too is to give you an idea of where Nevada could be if they chose to take a path that's available to them right now. And I'll tell you, any state can take this path, but Nevada's in first place because the law says spent fuel's coming here. And they spent their time in the last 40 years and a lot of your tax money fighting this. I spent a lot of my private time and effort to try to convince them not to fight it and to bring it in, not to bury it, but to use it. And so we'll talk a little bit about that today. So my understanding is that three big problems you're facing. Number one is water. Okay. I mean, clearly we have lots of water where I live. The East Coast has lots of water and would rather dearly love to give you some, but you're in a drought situation now where the water is kind of an issue and we don't have a way to transfer that stuff. So anyway, that's one. The other one is diversity of business. You want to diversify more into technological businesses. And the other one is grid security for electricity security. I'm sure you've probably read what's going on in the world about power supplies and stuff like that and how they're artificially moving towards a intermittent power supply of wind and solar and the troubles that's causing in different places. So a lot of what we're talking about today is a political versus a technical kind of a clashing of ideals. And I'm the technical guy. So I don't know how to solve the political stuff, but the technical stuff I can answer a bunch of questions for. And I have my theories on political stuff, and we can talk about that too. So it's a nice, comfortable little audience today, and I appreciate you guys being here. So I want to get started. Okay, so all you probably remember Yucca Mountain. You're probably, although you may be younger than me, you probably still remember Yucca Mountain and the issues we faced there. And we probably haven't heard Yucca Mountain mentioned maybe for a decade, because that all got put to bed. They're now going to something they think is called consent-based siting, and we'll talk about that a little bit today. But 40 years of and $13 billion of expenditure, they're no closer to a solution than they were before. Now, I'll tell you that the stuff that we're talking about is safe where it is now. It's plenty safe and plenty available. But when the government got into the business back in the early 70s, or the middle 70s, that's when the death knell for any kind of solution for this problem. Okay, that's the death knell for any kind of solution to this problem when it started. So how we deal with that on a political level is anybody's guess, but we as citizens probably need to take some responsibility there. So what this slide's telling you is we really want to bury it in Yucca Mountain. We want to use it to produce energy, and that was the whole purpose of regenerating this whole idea in Nevada. So here's a lot of reasons why Nevada can be #1 in clean energy. Now, I'm gonna probably say some things about wind and solar that don't sound very good about it as a business case or as a supply case. But if they want to compete in a fair market, I'm happy to have them. I'm happy to have them compete in a fair market. But as you'll see later, if you need subsidies to support your business case, it's costing way more than it ought to. And so we're having a dichotomy of that right now. And it's causing us to maybe face blackouts and see what happens to Germany and California this winter. So you can see a lot of the reasons here why Nevada has an excellent place. We do have a huge support for nuclear programs here. Most people don't know that. We have nuclear engineering programs up at Reno and at UNLV. We have the best radiochemistry PhD program in the country. And people don't really know that. And I don't know why, when you're talking about separation and dealing with these radioisotopic mixes, radiochemistry is the key to it. And we produce probably 10% of the PhD graduates here right at UNLV. And then I graduated from the health physics program here. So don't hold that against them. But it's a very good program, despite the fact that I got out. So we'll talk about a lot of these things down here, and some I've already talked about, and you can read them. There really are reasons why Nevada should want to be in this business, because that's where the business is going, clean energy eventually. Couple things people might not know about. And so I'm going to talk a little bit about a huge business opportunity. And why do we do nuclear power? That's the question that a lot of people are asking. Why be in the nuclear power at all? If you split a uranium atom, fission uranium atom, you release 50 million times more energy than if you burn a carbon molecule. So energy density, supplying energy from a very small area in a very compact system, is pretty handy, and it is really a good business case. And then the electricity business in the United States is $400 billion a year. Now you're talking about the government throwing around numbers that make that sound like chump change. But from a business perspective and from an economic perspective on the private side, that's a good chunk of business. All the energy sector is about 1.2 billion. So if you throw in gasoline and heating oil and all that other kind of stuff. But electricity is what we all want. And electricity is what we really can't do without. And you can see for the last decade or so, our demand for electricity in the United States has been pretty level, because we're doing a lot of conservation and we're doing a lot of not using our power that we have available to us. And so my opinion is that we invented all these nice things that we can use electricity to. Why aren't we allowed to use them? So I'll show you an option that we maybe to alleviate that. So here's the mix that we have today. It's about 20% renewables, about 20% nuclear, about 20% coal, and about 40% natural gas. And over the last decade or decade and a half, renewables have come up about 10%. Coal has come down about 10%, and natural gas has come up about 20%. So that's the trend that's happening. They consider natural gas is cleaner than coal, but it's still a polluting way to make energy. So it's sort of in the middle road there. And it's not considered clean, but it's cleaner than coal. So that's why they're moving to natural gas. Renewables, you can see the mix up there. So I want to talk a little bit about renewables and nuclear there. You can see hydro is included in the renewable side, but nuclear is not. So in my opinion, a better description would be something called sustainables. Because in my mind, whether you're producing, the earth is naturally producing your fuel source like wind and solar and wood, okay, is no difference than you have an essentially unlimited source of the power that you need. So if you're talking about available fuel at a fairly reasonable cost, then you need to throw nuclear in there. And so we call that sustainables. So it's a semantic thing that we're talking about. But if you can look at this kind of a different division of it, we have baseload clean power, okay, hydro and nuclear. And baseload means it's on all the time. You can leave it on. We have a measure called capacity factor, and the capacity factor for nuclear is about 95%. So if you have the capability to produce a certain amount of energy, capacity factor is how much of that energy you produce over time. So over time, consistently, nuclear produces 95% of its nameplate power. So if a gigawatt reactor, it's going to produce a gigawatt of power 95% of the time. And hydroelectric is a little less than that, mostly because it's based on the availability of water. Okay, so there's sometimes they don't run the hydroelectric plants because they're trying to either build up the water behind the dam, or they're trying to do, because actually the dams are made because they're controlling flooding and controlling water. Hydroelectric power is a secondary issue to that. But Lake Powell, as you know, lately, they're keeping the water in Lake Powell at the expense of Lake Mead, because that hydroelectric dam serves about 5 million people, and they're worried about that being able to replace that power. So water is not just keeping us alive and drinking water and watering our lawns, has a lot to do with the power mix that we have today. But it's important to remember that those dams weren't built because of hydroelectric power. They're built to control water. The intermittent clean power, we all know solar PV and all these things they're putting in place right now. Okay. So after all these years of subsidies and everything else, you get 12% of your power from intermittent clean energy. So it is clean and the fuel is free, but that's something they want to stress exclusively when they're talking about it. If you're talking about gigawatt power reactors like we have today, 4% of the cost of your power from a gigawatt power reactor is fuel cost. So that's almost free. They don't tell you that part. For coal and natural gas, about 80% of the power cost is from the fuel. So if coal price goes up, goes right up. Natural gas price goes up, the cost goes up. But the cost of uranium and the fuel for the reactor is a very small factor in what the overall cost of producing the energy is. So if you want to talk about either free fuel or 4% fuel, you're in the realm of very cheap fuel, and where fuel doesn't guide the energy of it. So then you're looking at the availability of it. And as you'll see, there's a huge availability. So here's where I'm going to kind of get down on wind and solar. Here's what Warren Buffett said about wind. If the government didn't pay me to put wind in, I wouldn't put it in. It doesn't pay. It's not a business case. And as you'll see, there is really the government subsidy is way more than it ever produces as power. And so you wonder what the deal is. And over here, you'll see, my slide comes back. There we go. Okay, over here, you'll see that the land use factor is quite a bit. Here's where the land use factor is for wind and solar. And you can say, yeah, the windmills are on farms and you can still grow plants on there, and that's true. But they take they cover a lot of area. And solar panels, it's kind of disgusting what they're doing. There's a lot of environmental organizations now fighting it hard, like they used to fight nuclear. They're fighting wind and solar because they're crubbing up the environment. And that's their mantra, is clean environment, clean air. Yeah, but what expense? So when you talk about land use, and land use is valuable, you need to consider that as part of the method for evaluating whether wind and solar is the way you want to go. And then actually these are included in the renewables. These are included in the renewables here. Base load polluting energies. So they call these renewables: burning wood, burning garbage, and burning biofuels, okay? Because guess what? Wood continuously grows, and we can grow corn every year and make biofuels. And of course, we make lots of garbage. So those are going to be continuously supplied power sources, so they're considered renewable, but they're very polluting. Wood is the most polluting. They used that back in the 1800s, but they're burning wood to make energy and burning garbage, and biofuels is actually burning food to make fuel. So when you think about this thing in the context, you got to think it in the whole entire context, and more like a business case, not like a gee, wouldn't it be nice if. So you got to look at some of these. So this is my view of the clean energy. So if you take the baseload clean energy, that's about 70% of all the clean energy that we're producing. And that's what we really need to focus on today. After all this time of subsidies for wind and solar, this is still 70% of our base load right here, of all our energy. So, okay. And then you guys know how light water reactors work. So I'll go over this really quickly. We mine uranium, we refine it, and we enrich it. So we get it from about right here, we get it from about a 0.3% or 0.7% for enrichment in fissile U-235 up to about 4%. And we put it in an oxide fuel pellets, but of this configuration. Lots of this is non-fissile 238. This little piece is U-235 fissile. Put them in little pellets, put them in long tubes there, and we make a fuel assembly. And that fuel assembly, as you all know, is very benign. You can stand right next to that. It's not radioactively hot, and it's not dangerous at all to have around. Put it into a reactor, though. See, over here you have a inner containment right here. So we put them in those inner containments because if an accident happens, you want that to contain whatever happens. And those are very robust systems and work very well, as we all know. And then when it comes out, after about 3 to 5 years, it has this configuration. Come on, baby, you can do it. It has this configuration here. And really, this number here was 96%, here's 95% here. So 95% of the fuel doesn't change. What does change is about 3% of the fissile U-235 turns into fission products. So that's going to be about 3% of the mix. And that's where the real high radioactivity comes. Those things are very unstable in their nucleus, and they release a lot of gamma rays. And they do so for a while, but they decay exponentially. So they're really hot at the first, and they decay faster than linear. But they're still pretty hot for quite a long time, and we have to shield them and keep them away from people for that purpose. But there's 1% of the U-235 left when it comes out, and there's about 1% of plutonium, other actinides, but mostly plutonium. Okay, so that's the mix when it comes out. The point I want you to notice is that this is all energy here. This is all uranium-based energy. All you got to do is figure out how to fission and get it out of there. So we're throwing away a bunch of energy if you throw this away. Goes into a fuel pond here, a water pond. You've probably already heard about the water ponds. Sits there for 3 to 5 years, depending on the burn-up rate. And then the decay continues. So that the water circulates through and takes off the physical heat. And that's about 30 feet of water that shields the radiation heat. So that under the water, you can walk by it. There's no radiation danger there. But when you handle them, you have to handle them remotely and in a shielded system when you move them around. But they've done that for years with nobody having any problem or accidents or anything with that. Then they go into a dry cast storage, which is really on this slide here. I need somebody to do my buttons for me. So after it cools down after 3 to 5 years here, it now can be air cooled. It can be convectively cooled. It doesn't need water anymore. It's down low enough heat that it doesn't need water, but it does need shielding. So these are all hugely robust concrete reinforced casks that they go into. This is Connecticut Yankee. This is the entire inventory of the Connecticut Yankee reactor that ran for 40 years. Spent fuel, last fuel, everything. It's inside of a chain link fence with a barbed wire top on it. And you can see people are working right next to it. Very benign. This has been sitting there since 1999. So despite, I think nuclear power is the only thing they talk about what might happen, not the history of what has happened. So that's a tragedy to me. And I just try to impinge on people and try to think a little bit when they hear all that stuff and try to listen to what's hype and what's not. and balance the truth on this, because this stuff is very, very benign, very, very small in volume and well protected. Never have we had an accident with that in the history of the industry. And if you add the nuclear navy to it, they ship the nuclear navy spent fuel. A lot of people don't complain about that and whine about it, but they do. They ship it all the time, 100% safely, and that's up in Idaho, sitting in a ditch in Idaho. Very benign, very happy to be where it is. So there's really no danger in all this. And this, remember this now, this is where all the spent fuel locations are in the United States. Fairly well distributed in the country, not so much on the West Coast, quite a bit on the East Coast, but they're not in one central location. They're all on the reactor sites where they were made. Okay, this is just kind of a little cartoon to explain how heat generating energy works. You guys all know this probably anyway. You have a heat source. This is a sodium cooled reactor, but you could use this for a gas or natural gas or coal or light water reactor, whatever you want. But the heat source heats up the cooling medium, mostly water and light water reactor. In this case, it's sodium, has a heat exchange unit here. Okay, so it goes in hot, comes out cold, right? And then the heat transfers to this method here, probably water. It is water if it's running a turbine, turns to steam and drives a turbine. That's how you get electricity. So 90% of our electricity is generated in this manner. Heat something up, boil water, run it through a turbine, and that's how we get energy. It's just, what heat source do you want to use here? Okay, what's the most advantageous for that? And of course, PV solar doesn't do that and hydro doesn't do that, but the rest of them do. Okay, and here's why you'll hear a lot of hype that nuclear is too expensive to even use today. It's not a competitive source of power. And my answer to them is, if we have a free enterprise system, who cares? It's a free enterprise system. The people select the best product that they want out at the end of it. And if you're too expensive, guess what? They'll select something else. Not how our system works today, but how I advocate that it should work in the future. But the cost of something is really immaterial, because if they want to sell it, they'll make it at a competitive cost or a huge enough advantage that you'll pay a premium. And that's the way business is supposed to work. So anyway, it has the best industrial safety record by far. This statistic is worldwide, includes Chernobyl, which Chernobyl is really the only accident that produced casualties from a nuclear accident in the commercial production world. Here's the competitive cost. This is solar. This is kind of an old chart. So solar's come down, winds come down a bit, but you can see that they're all pretty much competitively priced in here. Some are up, some are down, but they're all pretty much the same price to produce these clean energy sources. And this is the clean energy. So here's coal, oil, and natural gas. Here's wind, solar, and nuclear and hydro in here. Very low clean energy sources, very high clean energy sources. So you can see them arguing these numbers all the time, but that's where the division is. If it's clean in this range, it's clean enough. If it's dirty in this range, it's dirty enough, basically. So that's where the division comes. And this is what I talked about baseload, 95% for, I think that says 93%, 0.5, but somewhere in that range. The only reason for these two to be a lower percentage is because they're using primarily now to back up these. So a lot of it comes from these sources, but they're not on all the time, because mostly the laws say they have to use this energy first. So they got to turn the other energy off while these other energies are on. And it's a balancing act for all the utilities because sometimes they throw away energy because these just produce so much energy at the wrong time that they can't use it, but they're mandated to use it. And then you can see hydro in the middle there. Profitable, again, free market enterprise system where everything's equal and regulations are normal and all that stuff. Nuclear is hugely profitable. And it's mostly because it has a long half-life for the reactor. The reactor is the big cost for nuclear. The debt service on the reactor is the biggest cost that the nuclear reactor ever faces. So once they pay that debt service on it, it can run for another 30 to 50 years, depending on what politics do. They're closing reactors today because of politics, not because they're running out of capability, and they're closing them at their highest profit level. They've already paid off after about 30 years. Now they run 40 years, and like Connecticut Yankee here, they shut them down. Okay, shut them down, put it up on the pad. They have another. they can run up to 80 years. They've approved the designs to run to 80 years in the case of some of the reactors now. So it's kind of a travesty, and it makes you wonder whether free enterprise is really working at all, and whether sensibility is in the system at all for power supply. And that affects you guys because you pay for power. And it really is an issue that we need to come to grips with at some time. And if we do spent fuel recycling, which I'm going to talk about in a minute, you've all probably heard of reprocessing that France does, where they have a chemistry set, they mix them all up into a witch's brew and separate them all out with chemistry, and then reform something they call mixed oxide fuel that they can put back in a light water reactor plant and burn for another 3 to 5 years. But after it goes through that once, it's done. So now you have to bury it, and still more than 90% or 85 or so percent of the energy is still not used. But if we put this in a fast reactor, we can recycle and use all of that energy. And that's what I'm going to try to impress on you is probably a good idea. Here's what they're doing overseas with nuclear, and they're beating our pants off in competition overseas. And this is just a few of the countries. All the Eastern Bloc countries, Slovakia and Hungary and Poland wants to go 100% nuclear. Slovakia is 70% nuclear right now. You got Australia that's gone down the path and is coming back for anti-nuclear because they're just facing the reality that they can't do what they want to do with what they have right now. And if they push that system too far, they won't have power. Blackouts and brownouts and stuff people don't like. So this is the issue that's being faced right now. China is building reactors as fast as they can. Everywhere they have a water source, they're going to put a reactor, okay? Everywhere they don't, they're going to put coal fire, okay? Up in these areas here, so they're building lots and lots of coal plants because they're not near water, so we can't use nuclear, so we're going to still build a plant. And natural gas, and they still have wind and solar farms going, but they're phasing out of those and phasing in to nuclear because of the small modular reactor part, okay? So if you don't have a place where the big reactors work and you have a lot of open space, you can put wind and solar. But now with small modular reactors, you can move those in there. So they're going to start their first small modular reactor supposed to come online in 2024. And if you have a sparsely populated area up here that has very few people living in it, small modular reactors make a lot of sense. And they can have their own grid and supply people without having to tie all these big reactors into a grid and drag all this energy up here where not many people live. So they're pretty smart. The Chinese are pretty smart, and they're rolling through their logic on how they're doing nuclear power. And India has had nuclear power for years. They have 22 reactors online. The situation with India is lots and lots and lots and lots of poor people and very few rich people. That's how their system breaks up. So they're trying to bring energy to everybody. So they're building energy production facilities as fast as they can, but still there's people in India that don't have power. So they're going to thorium fast reactors, which is a fast reactor, thorium fueled instead of spent nuclear fuel fueled. It's the same concept. You're changing thorium-232 into uranium-233 and then fissioning it. So you're making it and fissioning it, making it and fissioning it. And that's what they're going to, because guess what? They have lots of thorium in India. And it kind of makes sense. Okay, Russia is the export leader in the world of reactors. They're in 23 countries, building reactors for Africa and Asia and Middle East and some even South America. So they're exporting reactors just as fast as they can. I don't know why they're doing it with the war going on. I don't know, but they're exporting, and that's the thing that's going to be the competitive edge for them in the future. All these countries are moving way out on nuclear power, and we're still behind because I don't know, because of politics is what I think, but you be the judge. And then, so here's a USR. No, there's no SMR in construction right now. No small modular reactors in construction. There's only one approved right now. And it took them $500 million and 7 years to get an approval for the NRC. It's the safest production of power that there is with a 60-year history, and small modular reactors are even safer than the light water reactors. And they took 7 years and cost them $500 million to. So my opinion is they're slow rolling nuclear for a political reason. There's no other answer to that but that. And it upsets me no end because I'm a real free enterprise guy. I think we should compete everything. So that's what you're facing. But we still have, well, I think we have 93 reactors on. They closed one in Michigan since I made these slides. And we still produce 19% of the power and 55% of the clean power, even though they've been closing them down because they're making them more efficient. There's a big effort now to when closures come on, instead of taking 6 weeks, they want to take 3 weeks. And so they're online more often. So they're keeping up with the efficiency and the capacity factor, but they're closing them for artificial reasons. So we're in trouble with that. Now there's 2 reactors under construction in Vogel, Georgia. They're going to be done, one late this year, one late next year. They're actually fueling one now. So it's getting to the end of the process in that. But they started those before Fukushima. And what happened is when they started constructing them, the NRC forced them to take some of the stuff out and retool them for some kind of a Fukushima safety issue. We haven't had a safety issue in the United States from any of our reactors for any of the years, but because of Fukushima, they decided to put more safeguards on them. So, you know, if you build half a building, you have to tear it down. It's probably a little more expensive and it can take a little more time. So they're blaming nuclear, high costs of nuclear on that. But if you dig deeper into it, you find out it's not really the companies that are the problem. I mean, there's some culpability there, but most of it is the NRC making them do other stuff. So it's hard for me to be convinced that the NRC is on the side of more nuclear. It really is. So we do, though, they're under construction. The last one that opened in the United States was right here in Phoenix in 1985. So this one will open in 2023. So you do the math. That's the amount of years between you had a light water reactor open. Last one open, well, 88. So 88 to 22, what's that? 34 years? To me, that's unacceptable. Might be 44 years. You do the math, though. The big numbers scare me. So anyway, that's the issue of the competition overseas and what other countries are doing. And that should cause us to have some thought processes too, because if they can do it, certainly think we could do it because we invented the technology. So, and this is an interesting concept. So y'all know the nuclear Navy. If you know the history of the nuclear Navy, Hyman Rickover saw the vision of the strategic capability of having a totally quiet power source that never need to be refueled, never, okay? The whole life of the submarine, well, okay, aircraft carrier once, submarine never, okay? Saw that vision and pushed that through all the naysayers and all the people and finally came up with a light water reactor design that ran these subs, launched the first one in 1955 before any commercial reactor was online. And now there's almost 100 of them out there floating all the time with absolutely no problem at all, ever. And it's such a strategic advantage. I mean, you consider that what these people aren't they? You consider that it can stay down. It could technically stay down forever because they can make water and they can carry a lot of food and they can make their own air and they have an unlimited power source. The trouble is people want to come up every once in a while. So that's the limiting factor. And also people want lettuce sometimes to eat and maybe fresh steaks and things instead of box lunches. So every once in a while they can come up, but they generally deploy for 6 months. And in a situation, in a crunch, they could stay down and everybody would survive for at least 6 months and maybe more because they have an unlimited power supply sitting in their belly there. And like I said, no ramifications from nuclear exposure or anything for the whole process. So then Russia thought that, wanted to do that as well, right? Because they don't want to have their diesel fuel has to come to the surface to fuel. You can hear diesel fuel for hundreds of miles away. So they wanted their reactor. So that's what they did. They went and made their own facility for us. And now finally China is on board. They have the most modern aircraft carrier, nuclear-driven aircraft carrier and submarine force in the world now, and build them as fast as they can. So now we have 3 nuclear submarine forces, and we're going to sell some to Australia apparently. And that made France mad, but I don't, who knows how that all works. But they all want them now because of Hyman Rickover. Well, the same thing's happening now with the Air Force. So they thought maybe the Army and the Air Force could use reactors in the early days, 60s. So you had very successful programs in that realm, but stopped them about the Vietnam War because at that time, they needed to make choices on where to spend the money, okay? So they decided to stop the nuclear program to fund the Vietnam War, and it never really took off again, but it is now. So now they're seeing the advantages of the power. Here you see a different slide that I didn't want. And here you see This is what the convoys have to bring up to the front: fuel and water. Okay. In modern warfare, people die in the convoys. More people die in the convoys than die in the front end. So if they can reduce the amount of this stuff that they have to bring up, they save a lot of lives and they save a lot of money, because it costs $3 a gallon gas in the rear, costs about $300 in the front. So you really have an effort to save a lot of money. Plus, you don't have to run generators all the time. So you can make water, you can make fuel if you have enough power at the front. So they're thinking that a 5 megawatt small reactor at the front could alleviate a lot of these issues, and that's why they're doing Project Pele. And then the strategic bases like Nellis and Creech and that are finding out that the national grid's not as stable as they'd like it to be. They're worried about whether they get a consistent supply of power from the national grid in the state that it's in. So they're moving towards small modular reactors for a base like Nellis or a base like Creech. And we were in really good conversations with Creech for a while to be the first one, but since no nuclear Nevada didn't want to, take up the bandwagon, it's going to go to Alaska because Murkowski convinced them. So by at the end of 24, they'll have their first prototype of one of these reactors. There's 2 companies down selected for that, and they're going as fast as they can to get this developed. And the military will pay all the development costs, but they want somebody to market to them. They don't want to build their own because they're terrible at building their own. So they want a company to go out and get a profit motive to make them and sell them back to them. So they're at the point where there's a couple of these. Now they're opening it up to Rolls-Royce and Westinghouse and Northrop Grumman, I think, and some company I never heard of called Thrust. I have to find out. It's a company I never heard of, but they're entertaining them as a source. So we can see that the strategic goals for the strategic bases is to reduce the risk of national grid power failure. And so if they can make cheaper power on base, they'll use it. If they're connected to the grid and it's working, they can use that. Either way they go, they got a choice. And they can probably even produce excess power to supply a town in an emergency. So it's a real nice, slick idea. And then of course they put them on the front lines and they can make all the power they want. Data centers, they can even make parts now. They sell something called adaptive manufacturing, which you probably call 3D printing. For metals, they can just put a design for a part in and make it. It's not perfected yet, but that's what they're doing. That's what they're moving to. All takes power. So they realize that nuclear is a compact power source. They really like it. So this is happening in real time. Okay. So here's what my idea of recycling used nuclear fuel is. Remember, the goal is to take that 95% that isn't used, plus the plutonium, plus the rest of the U-235 that hasn't burned, turn it all into power. So 3% fission products, 3% of it burns in the original reactor. So 97% is less. So you got about 30 times the energy potential in spent fuel than you had in the original energy. Okay. That's a powerful tool. Okay. It's already mined. It's already refined. You don't need to enrich it anymore. And with the fast reactor technology, the fast reactors will fission all of it. You've heard of a breeder reactor. So you can have a breeder or a burner reactor with this technology. So U-238 can take a neutron, turn into uranium-239, beta out twice to plutonium-239, which is fissile. And actually, in a light water reactor, about 30% of the power at the end of the life comes from the plutonium that's been transmuted. So this is the idea for the whole. All of it can go, all of it can fission. So a homogeneous or a liquid fuel, they mix the spent fuel in with the molten salt, spent fuel salt in with the molten salt, and it fissions in the coolant. Okay, can't melt down by definition. The thing about molten salt designs too is can burn very much hotter than liquid water reactors, light water reactors. The light water reactor is under about 2,000 pounds of pressure because you have to keep water about 300 degrees. The only can do that is put it under pressure. So that's why they have the real issue with all the pipes and everything, and they got to really have good welds and everything, and they can't have leaks. This runs at atmospheric pressure. Salt melts at about 500 degrees, and you can run it between 500 degrees and 1,100 degrees and use that difference in the heat advantage to produce an efficient energy production. So it's about 100 degrees for a light water reactor It's about 500 or 600 degrees for a molten salt reactor, and the efficiency is based on the difference in the input and output heat. So there's a large efficiency advantage for these reactors. And so this is the liquid fuel reactor. This is a company called Elysium, and that's doesn't exist now. That's their idea of what it would exist when they build it. And this is the experimental breeder reactor 2, which I think Don is familiar with quite well. Yeah, one ran for a little while. EBR2 ran for 30 years. So it ran on the concept of pyroprocessing solid fuel. So they had a lab, a hot cell lab, where they would consistently make spent fuel pellets. Okay, and they go into the reactor. When they burn far down enough, they come out, take the fission products out, take whatever's left and put it in with spent fuel and roll it through. There's a continuously process, totally automated, that made this, and it ran for 30 years. And in 1985, they simulated the 3 Mile Island accident, which was a loss of pumping power to the reactor. So they shut the pumps down on this, and the people just take their hands off the console and watch what happened. And of course, the temperature went up because guess what? No cooling, right? But when the temperature goes up on this fuel, it expands. When it expands, the criticality goes down. So less fissions happen. And they watched it go up to about 1100 degrees, and then it went and shut down all by itself. So this is called intrinsically safe. If all the people in the reactor house die and the pumps shut down, it doesn't melt down. It doesn't shut down. It shuts down gracefully, doesn't melt down. And so that was and then they repeated they repeated the Fukushima accident even before it ever happened, which was offsite power being lost. Okay, so now kind of the same thing. The pumps don't work anymore from a different source of reactor. Same thing. Heat it up, cool down, no problem. They did both of those experiments in the same day, 1985. So proof of concept was a pretty good aspect of that. Now this is something called the natrium reactor, and that's Bill Gates' idea. And he claims to be putting one of those up in Wyoming by 2028. But he hasn't even submitted his approval for licensure yet. So remember, NuScale, 7 years, $500 million. We'll see how much Bill Gates really has to pay to get his licensed. Because, you know, wind and solar doesn't have to go through hardly any scrutiny at all to get installed, but nuclear has to jump through hoops for 7 years and $500 million. But Bill got a $1.4 billion to help develop this from the government. So maybe they're saying, we're going to give you some dispensation. I don't know. He says that it's off a design that already started the development and the approval process. So maybe you can piggyback on that. But we'll see. But he sold the Wyoming governor that he'll have one in by 2028. 6 years from now, hasn't started to the license to pursue. So we'll see. And his is not based, it's a sodium cooled reactor with a secondary salt cooling system. Okay. Pretty novel and pretty out front kind of design. So the sodium primary coolant, you could burn spent fuel in there. You could burn thorium in there, but he chooses not to. He's going to moderate the neutrons, and he's going to burn a fuel called HALEU, H-A-L-E-U, high assay, low enriched uranium, which is not made yet. So they're going to have to go through a process to develop a whole company that's going to make that fuel. And it's, instead of enriching it, remember I said 4 to 5% for reactor fuel, they want to enrich it to less than 20%. Because you enrich it to 20% or more, it's what? Highly enriched uranium. Now we can't have any of that in a reactor system. So 20%'s out, but 19.99999 is okay. So essentially 20% enriched instead of 5 or 6%. So it burns for a longer time in the reactor. And but the novel part of this salt part is that he says he can make big repositories of salt, of heated salt, and it's got a great capacity to hold heat. So it can hold heat for a long time. So his idea is they can use this capacity of the reactor heat to be to intermittent to fill in for the intermittent solar and wind. So that's his design concept for the whole thing. So with the sodium heat, you can switch to sodium heat, high heat. You can use what they call process heat to make chemicals. You don't have to burn fossil fuels to make high heat. You can just use the high heat to make chemicals and hydrogen and all that kind of stuff. Or you can use it to make electricity directly, or you can move it through this molten salt system and store it for having heat balance later. Okay, so that's his idea, pretty good idea, but he sort of has an inside track, it seems like now, because of who he is. Okay, so a question burning on your mind, what's in it for Nevada? We have a state that's mostly BLM land, wide open spaces, with a population center here and a population center a little less up here. The rest of this is wide open spaces, and you don't need water to do small modular reactors, particularly fast reactors. So this could go anywhere, okay? So the concept is that we want to encourage the governor to say, I will accept use nuclear fuel into my state if, okay? So if you do that, now there's a $45 billion congressional nuclear waste fund growing at about $1.6 billion a year sitting there. And that came from money that they collected from ratepayers. It wasn't a tax on everybody. It wasn't income tax. It wasn't printed money or anything. They collected this money from ratepayers that they paid into this fund. So it's now up to $45 billion. That's where they got the money to study Yucca Mountain, $15 billion. And still 40 years later and $15 billion later, there's still three magic beans, right? There's no closer to a solution than ever were before. But if we turn this over to private industry, this is 14 billion's enough to transition a private industry to the production shop for recycling spent nuclear fuel and making energy off of it, okay? It's a no-brainer to anybody outside the government, at least to me. I don't know anybody who doesn't like the idea, because it's such a huge possibility for economic benefit and actually benefit for all, because essentially unlimited energy. So there's 250 years. Remember, you saw all those sites where the spent fuel is sitting on the United States, about 90,000 metric tons. There's 250 years worth of power, all the power the United States produces sitting on those pads, 100% domestic, 100% clean, because they're already mined, already fined, and they don't need enrichment. So you use the power right directly into the reactor plant, whether you use the solid fuel or the liquid fuel idea. And there are already private companies developing these designs. That's the amazing thing to me, is that they watch NuScale go through this horrible, torturous path to get licensure in the NRC, and there's still 50 privately capitalized companies working on nuclear energy as a business, as a small business. And every one of the large reactor companies have a small reactor design, Westinghouse, Northrop Grumman, General Atomics, all those guys. They're just biding their time until they feel like they can get over that hump of, why do we have the safest power production source in the world, and yet it has the highest hurdle to get over and license? It's insane, but about $3 billion worth of private investment has gone into that. And I don't know if anybody ever start businesses try to get private investment. Pretty grueling, okay? But 50 different companies were successful at, and they're working now every day developing these designs. So the advantage of that is if you want to develop a new idea in the military, mostly the military, it's a little bit in DOE, but mostly the military, you cook up a good idea in DARPA or somewhere, all smart guys think of fine ideas and do the basic experiments on it. But the game is to try to now get it to the point where you have a prototype and you can interest a company and invest the money in making it. If you make it, we'll buy it, okay? These companies are already in business. All they got to do is move it from design to engineering, and they're ready to do it. It's just that one little push over the top that they need. But when you talk about risk versus benefit, all we ever hear about is risk, okay? Well, I'm trying to talk to you about benefit. So 250 years worth of energy sitting on each of these pads in the United States, and we really only need 100 years, because in 100 years you'll have fusion or space-based power. Who knows, even our kids will be dead by then, but somebody will think of something better, right? And so you're going to want to burn this as fast as you can. You want to use this, once you get this going, they want to turn it into from $1 million problem, a $1 million year problem, to about a 100-year problem. They say 300, but most of it's decayed away about 100 years and is pretty safe by then. So that's a benefit, not a $1 million year problem, a 100-year problem. We can make lots and lots of money from selling energy off of this. And now you solve the biggest issue that people have and are worried about, spent fuel. They think it's a huge liability. If they bury it in the mountain it's going to cost $400 billion. And there's not enough capacity in this Yucca Mountain design to do it. They'd have to have a second one. So you're facing an almost $1 trillion liability from spent fuel when we have an idea that can turn it into almost unlimited energy at a very low cost. So my concept is to get it competitive, and then you'd have an idea like you have cell phone service. You produce it and you want to burn it up as fast as you can because you got 250 years to burn up in less than 100 years. So you want people to use it as much as you can. Remember when you guys are here long enough, probably remember when Lake Mead was going over the spillways, right? Open up and water your lawns, open up the water, drink lots of water, whatever, lose all the water, they said. Of course, different story today, but get a lawn, pour it on there. Yeah, it's great. Same thing here. We want to use it up as fast as we can. So imagine a world where you have almost an unlimited supply of electricity. Right now, they got you convinced it's a very precious commodity. We got to conserve it. It's worth a lot of money when we sell it to you and all that stuff. When this concept is you can pay $100 a month, get all you want, use all you want. And you can use your mind to open up the possibilities for that, both in commercial and home. You can run the air conditioner 24 hours a day if you want, freeze yourself out, heat all winter, no worries. And and you're helping because now you're consuming more of this waste product. So anyway, what we encourage is a governor would say, it could be any governor now, doesn't have to be Nevada governor, but because of this 2000 Blue Ribbon Camel, the state can define what consent means, and it can define the benefits it wants. Now, what state wouldn't do that? I mean, it's just beyond comprehension while all these states are still fighting it. So what we would recommend asking is to get 2 first-of-a-kind fast reactors built, because the most expensive one's the first one, okay? So get 2 commercial design reactors built on the test site. Once they're working, you can build a manufacturing facility right there. Could be in Hawthorne or Ely or any other state for that matter. And then you build these in a central location, you ship them to the site and install them. You don't go out there for 7 years and build them on the site. So these are you could order them like a refrigerator or an air conditioning system. And once they get into production shop. Now this is the fuel burning. There's lots of other different small modular designs, and they all have different little niches in the community. So you'd have all kinds of different companies manufacturing different types of like lawnmowers or anything. There's all different types for all different applications, tractors and even cars, different kind of cars for different applications. So this is what you could drive energy to. So we'd ask for that. Build us the first 2, the expensive first 2, and then they can start cranking out the rest of them in a repository. National Tech Transfer Laboratory, if anybody ever worked with the national laboratories, they just never want to end a project. If they end a project, they got to find another funding source. So they're all basic research countries. There's no end to basic research. So there's 60 years of basic research sitting on the shelf there because they're really bad at tech transferring out to companies. Well, if you had a central lab whose only job was to shop those other all those national labs and accelerate this out to the businesses, well, no telling how much economic benefit we get. And I talked about Project Pele, so you could ask for the applied engineering. Once you get these reactors going, we want you to come out here and test them and use them and see how they work and make advanced reactor corrections and test for safety issues and everything. That's a huge business. Now we want an industrial park. So we want clean energy projects to have an industrial park right outside the national laboratory. So these people would come and locate there, headquarters, manufacturing facilities, research facilities, and they'd be next door to the lab that's going to find them all the discoveries in the other national labs. So you can imagine a routine operation there where they supply requirements. These guys supply answers in a very real-time method or almost real-time method instead of now where they go on the shelf and, well, if you like something, maybe we can talk about getting it to you. You could ask for easily $100 million a year for university programs. If you know universities, $100 million a year is like unlimited money. It's just a tremendous amount, but in this context, it's very little. $45 billion, you could shave off $100 million a year. And so we wanted to get microgrid research. You could get them asked for that. Their microgrids are smaller grids powered by a central location that can be severable from the national grid. So the national grid goes bad, you sever that from that, you still have power in the local area. None of those, that's what the military concept is, but we could do that in the local concept. The MGM Grand uses it needs 53 megawatts of power. The new scale reactor is about, the old one's 54, the new one's about 70. So you could dig a hole out there, put a reactor and power his entire casino and have extra power, because that's peak power, 50. So sometimes they use less, they can market to the external source, but they don't like nuclear. So there you go. And then you can use your imaginations. I'm sure governors can think of other things to ask for, okay? But if you get this going, this is enough money to make it work if you use private industry. If you leave this to the government, it's never going to get done. 40 years, $15 billion, 3 magic beans, okay? And now, since they own the spent fuel, they're paying about $800 million a year to the reactor companies to store their spent fuel because they own it. It's very, very safely stored, and it's no accidents, no incidents, no anything with it. They know how to do it, and they kind of like the money, you know. So reactors might be not in favor of trying to use it because they like the free Uncle Sugar money coming in. So, but I'm a big favor of private industry. So if we drive it to private industry, let the government pay the upfront costs, you have a solution for $45 billion, not $800 billion. Sounds pretty good to me. So all you guys in the audience can ask me questions about, let me enlighten me on why this is a really bad idea, okay? Because I haven't heard it yet. So anyway, other industries could come here. Electric cars are going to move that demand from about 400 billion a year to about 600 billion a year if they sell all the electric cars they think they are. Now they're having trouble with that now because batteries weigh a lot and they don't last very long. They're running into that problem. So Tesla is a private company that's doing it. So they're going to figure out a free enterprise solution to that. They'll either make the batteries better, or they'll give you free batteries later, or they'll lose something because they want to sell their cars. So it's at least being solved, but there's, I think, I don't know, is it 2,000 or 3,000 pounds of batteries that go into this thing? And they cost like $11,000 or $12,000 to replace. And so people are having horror stories now 7 or 8 years later. Well, it was, you know how warranties are, right? Oh yeah, the batteries, so just replace them for me, please. No, well, you know, you parked too close to the fire hydrant, and if you read in the bottom, yeah, you can't do that. So it's all on you. So, well, you know, the insurance, right? There's always a clause in the bottom of the insurance says, we'll cover everything unless it happens to you. Okay, then we'll talk about it. Now, I'm being facetious. There's a lot of good companies out there, and I've had good luck with some and not with others, but that's kind of works how it works sometimes. We could make chemicals and syn fuel. Remember, I talked about the process heat. So you can make fuel that you need, and you can make chemicals like mostly ammonia is what are really demand for fertilizers and things like that. That's really having a problem right now. But you could make those with the extra heat that you have. You can think of a lot of other clean energy technologies, and you can use solar and wind where it makes sense. So let solar and wind compete in the marketplace. Don't give them subsidies. The way the subsidies work today, there's hundreds of billions of dollars for solar and wind, tens of billions of dollars for petroleum products and oil. And they just announced $6 billion to try to save nuclear reactors. So if you're a utility company and they're offering you hundreds of billions of dollars to put windmills in and solar plants and $6 billion to save a nuclear power plant, is that going to turn your head? I don't think so, but all the guys in my profession, there's such a great news and a great, I don't know, we'll see where it comes out. But remember, 10%, 12% is what we produce in energy with solar and wind. So that's maybe $50 billion a year out of 400 billion. And so the subsidies for that are $100 billion and on the order of hundreds of billions of dollars. Now, what kind of investment would you put in hundreds of billions of dollars to drive a $50 billion revenue stream? It just doesn't make any sense on any business level. So again, all you guys out there can enlighten me why that makes sense on a government level, but people think it does. I don't. So anyway, there's still a place for solar and wind, but it has to compete in the regular marketplace as far as I'm concerned. This is a new scale reactor. We showed you that. That's approved, so they can start marketing that. Guess where they're marketing it? Eastern Europe. Poland, Slovakia, Bulgaria, Romania. They got their offices over there, marketing it over there because they're not so picky about the approval as we are here, okay? Thorcon is the leading thorium reactor company. It's a U.S. company headquartered in Indonesia, because guess what? Indonesia wants those reactors, and they're going to let them put them in with a lot less overhead than we are. So something to think about. High-speed transportation, we've been talking about that, steel rail and high-speed rail and everything, but there's a technology called superconducting magnetic levitation that's been commercially viable for a decade at least, and they're using it overseas in some places. If you go to Singapore and right from the airport to town, you're on a superconducting maglev train going 400 kilometers an hour, but not here. So if you superconducting maglev has the advantage that you've used very little energy. You can go up the hill and use energy because it's superconducting. Because there's really no resistance. And then you come downhill, you're putting energy back into the system. So you very little energy that you use along the way. I mean, there's always some friction and some loss, but almost none. So the concept of a water train has been bandied about. Build the rails out to the Mississippi River, rails back here, keep the trains rolling back and forth, dip them in the Mississippi River, fill them up, and then dump them in the Colorado River. 40 years from now, when the Colorado River's flowing and the Mississippi needs to dip them in the Colorado and run them out to the Mississippi River. So those ideas are pretty foreign and way outside the box to most people, but they're very practical when you think about them. And then while they're not moving water, they can move cargo, they can move people. They're very valuable. Remember we had the tube out here, what was that, Faraday Futures or something, had the tube. They're going to run the tube in there, so going to evacuate the tube, run 700 miles an hour, okay, because no wind resistance. At 700 mile an hour, even a few molecules of air is a problem. But you can run these at 400 miles an hour all day long and in the regular atmosphere and be fine. So do you want to go to that trouble just to get 300 more miles an hour? Some people like speed, so they might do it. You know, they drive cars pretty fast out here, I can tell you. So that might be a market for that. So anyway, we make all the water we want. If you have unlimited energy, you can have unlimited potable water. It's a very, very advanced technology. The desalinization plants. So you find a source of salt water, which I don't care what you say, we're not running out of salt water. In fact, they're worried about too much salt water can flood in all our shores now. So maybe they would like having us taking more water out of the ocean. And they say, oh, it's hard to get a permit to do this. Well, go to Mexico. I bet they'll give you a permit. You know, there's lots of salt water around. You don't have to get it from California. And then grid security is a big issue. It's a really big issue that's coming into the horizon now, and people just don't realize it. And this type of power could really alleviate that system. The grid is a amorphous, huge engineering marvel, but it's getting old. It's vulnerable for cybersecurity, and especially for something called electromagnetic pulse, either natural or man-made. So we're in a precarious area with this where it could take out, if they take out transformers, you won't get them built for years. And and transformers, you think of transformers, little transformers you have in your little power supply. These are the size of 2 railroad cars, these transformers. And there's issues with them getting supplied from China. Don't get me started. But that's a grid security issue. If you have a microgrid with a reactor running in the middle of it, you have a chance to buffer yourself from that. So the future will be competitive, marketed power systems that go onto a grid or onto a local area microgrid and compete with other energy sources so that you can choose which power. Now, they do that in Texas. Texas, you can choose your energy company. You can choose your electric energy company. And they all advertise like, you know, like Dish Networks and everything. Hey, pick me. We'll give you, we'll give you free 2 months of electricity if you pick us and run for all that whole stuff. But they're competitive. And they say that's the problem in Texas because it caused their problem in the shutdown. But the problem really was intermittent wind. And that the fact that they used natural gas for heat, direct heat, and for electricity. So you can only shove so much gas down a pipeline, and they had to make a decision. I mean, they had to make a within the minute decision on who to shut off, or everybody would be shut off at that time. It was kind of a beyond design basis kind of an effort. But That's what happened in Texas. Now you watch California. Now they're even talking about keeping the Diablo Canyon reactor going. And now, after all these years of wanting to shut it down, they shut down San Onofre way before 40 years before its design effort was done. And they're trying to shut down other ones. Palisades just got shut down. Indian Point is a huge sticking point in New York. So watch New York, because New York can't replace that power. That they don't have the capacity to replace that power if something goes high order, cold or hot or whatever the demand is. Because that was 50% of the power that went to New York City came from that Indian Point reactor. And in the United States, when we shut down reactors, we immediately start taking them apart, because we pay so much money out of our fee for nuclear power for decommissioning. That's a huge financial incentive for people to come in and use that fund and take it apart. So they shut the switch down. Guys are the next day taking things apart and moving things down. Not in Germany. Germany still has their reactors all sitting there. So it would be difficult and hard technically, but they could do it. They could bring their reactors back online if they wanted to. But they're still arguing about whether they should leave the 3 reactors they have online, leave them online, or take them offline. Meanwhile, France isn't going to give them power because their water's too hot in their rivers now, so they're cutting back on their power. So guess who gets the power when it cuts back? France gets it. They're not going to export it to anybody else. So it's big, huge, no Russia, natural gas, and all that stuff's coming to a head. But these people won't give up on nuclear power. They won't give in on their resistance to nuclear power yet. So we're at a place where really nuclear power is coming into vogue. They just don't realize it yet. You're going to see this next decade really expand with nuclear power. And all these businesses know it, because despite this situation with anti-nuclear, $3 billion and 50 companies, startup companies, are robustly, actively moving forward. Investors are sticking with them, even though they can't market anything. So it's coming. So these are the other aspects of, and you can think of others maybe, we don't have any salt water anywhere, so we'd have to go trade water with California or something, or make a deal. But I bet if California gets starved for energy, and if they get starved for water enough, I bet they're open to any ideas, okay? So when people say to me, oh, well, it's against the law, or, oh, well, we can't license it, I guess, well, you got a legislature that can change the law, and you got a regulatory thing that can change the regulations. So when they get desperate enough, guess what happens? Oh, maybe it's not so dangerous anymore. Okay, so it's something to think about. Anyway, this is the idea that we had running in here about 5 years ago with Nevada and Scan. But I have to give a tribute to Bob Franks, who really pushed this in the political realm. I want to be a technical guy. I don't want to be out in the political realm. It just makes me sick, and I don't know how to do it. But people have to venture into this realm to make these people understand and bring them around. And Bob Franks is doing that. And he passed away. He had some liver disease that got him real quick, and he passed away. So the core of this group is still here. They're just fractionated, and they're not cohesive now. But we're bringing them back together. And remember, the goal is to get the governor to say, I will accept use nuclear fuel if you'll use it in fast reactors to make energy, and you'll start it here, national lab, industrial park, ask for all that stuff, okay? So somehow we, the people, have to move it forward somehow. And it's not going to be just us here. So it's going to have to be a national tragedy that's going to really move people's attention away from it. But I don't see us avoiding it unless we start moving. So, buckle up. Is my opinion anyway. So here's why Nevada should do it. You guys can read all those, but most of it has to do with, we already have a technical base here of people who know how to do this with the test site. And we already have university programs that can easily be morphed into bigger university programs and train all the people. These are the highest paid technical jobs. So unions are all overdoing this. Even now they're all overdoing this. It's just they can't say anything about it. So once the movement starts, it can really start rolling. But Nevada has, and Nevada's in first place to do this. The law says spent fuel will come here. And except for 40 years of $5 million a year in Nevada fighting it, with mostly going to attorneys, it would be here. It would never get buried, because we'd eventually figure out to recycle it, okay? In my opinion. So that's what our whole mantra was: get it here and own it, and you can control its destiny. But nope, they didn't want to do it. Now, if this was all approved today, and they decided to go ahead and move the spent fuel out here, the first molecule wouldn't get here for at least a decade, probably more. Okay. So it's not like there's going to be trucks lined up at the gate with loads and loads and loads of the stuff on board. Now, if you had a let's go to the moon in 9 years effort put to it, yeah, you could have an impetus, because guess what? You can fly it out here, haul it in C5s, fly it out, land at Desert Rock Airport and haul it out to, that could work. And I'll tell you, the people in San Onofre are nutso over this. They want that spent fuel off of San Onofre, and they're radically protesting it being there. They don't have any idea where it should go, and they don't want to transport it on the roads, okay? But they want it out of there. So maybe the Enterprise can come back in the past and beam it up or something. I don't know, but the people are ridiculously bizarre in their demands. And so there's congressmen, of course, who are, oh yeah, we're going to start a commission and we're going to talk about this and we're going to figure this out and somebody's going to take this, by God, or else. And so we could make a deal with them. They'd probably pay us, I don't know, billions of dollars if we'd take it. Now, it turns out the San Onofre is on Camp Pendleton. It's right on it. Marine exercises going on all the time, right next to the shores. So they could truck it in Camp Pendleton up to their airport, put it on C5, fly it into Desert Rock Airport, done deal. Now, people, oh, what if it crashes? Well, how many C5 do you see crashing? I mean, are they every day one landed on the strip and crashed in the buildings and everything? I mean, you just don't hear C5s crashes. So why would they all of a sudden start crashing? So it's all these bizarre. I'll tell you a funny story, and I'll even say the guy's name because he's proud of what he says. His name's Ed Lyman. He's with the Union of Concerned Scientists. He's their scientific nuclear expert. Okay. And his concern for them down there is, what if, because of climate change, this is right next to the water and the water levels are going way up. And what if the water covers that spent fuel? What if? Okay. First of all, the spent fuel spent the hottest time of his life in water. Okay. For 5 years, 3 years in the reactor, 5 years in the water cooling ponds. And now it's convectively cooled outside. What would the water do to it? He never follows that sentence. And so if the water raises like 50 feet in San Diego, I think the people in downtown San Diego are going to be saying, oh, we better get out to that San Onofre and worry about that spent fuel, because I don't know, who cares if all our downtown's flooded with water? We better run out there and figure out that problem. So this is how silly the thing is, but people eat it up. Yeah, next to the water, oh, that water goes up now, we'll all be in trouble. And they used to say here that every time a chlorine truck would crash, imagine if that had been a spent nuclear fuel container. I'm imagining, okay? And so what would happen is they'd take a crane and they'd pick up the canister, they'd put it in another truck and it would drive away. Whereas the chlorine fuel, that they actually had a chlorine car cut loose and run 10 miles through town, that kind of just went by the wayside. They talked about it and it went away. If that had crashed, we'd kill 30,000 people. So again, risk versus benefit. You know, you got to think risk versus benefit. And when they all talk about risk, we all get scared, I guess, and stuff. So anyway, I think this is the time for questions. I just want to remind you now that spent fuel is worth, the spent fuel in the United States on the pads now at 1 cent per kilowatt hour is worth $10 trillion. Okay. At 1 cent per kilowatt hour. At 10 cents per kilowatt hour, it's 100 trillion. Now, what people don't realize is $10 trillion is $30,000 per person. I mean, they bandy about $1 trillion on the budget like it's nothing, but $1 trillion is $3,000 for each of us. So when they spent $2 trillion to send you $1,400, okay, well, it didn't even pencil out for me, because that's $6,000 to get $1,400. But if you're a family of four, $24,000 to get it. So you got to realize what they're telling you when you listen to it. And people associate millions with billions with trillions. They don't think about it. But if you tell them that a trillion is $3,000 per person, and a billion is $3 per person, and a million is 0.3 of a cent per person, that makes a contrast that they can understand. But the millions and billions and trillions, they don't even fathom it. And we're bringing out another $600 billion bill up there now.
Does anybody have any questions for Mr. Curtis?
Yeah, I just want to remind one more thing.
Okay.
First, we have the first right of refusal for this. We can define what consent means, and we can define what benefits are. I contend to you that there's no better deal in the last century for anybody to take on than this. And if we are slaves to electricity, we're slaves indeed. So if they get a monopoly in wind and solar, and we're told what to pay for electricity and told how much we can get, we will not be able to resist it. We can resist food shortages and health shortages, COVID diseases and everything, but we won't be able to resist this. So part of the effort is to generate competition in the energy business. And you'll have a lot of people tell you that that's not possible. Nevada Energy will tell you that that's not possible because guess what? There's the monopoly for energy in this town. That's the way they like it. So I will go ahead, Joe.
Well, thank you again, Mr. Curtis,
Sure.
for speaking today. Do we have any questions for Mr. Curtis?
You better have some.
All right, perfect. So
Yes, ma'am. Oh, go ahead, Joe. Oh, I'm sorry. He's going to pass. Then one of the microphone gets to talk. Okay.
Just out of curiosity, does the environmental impact study for the Nevada test site cover that?
Well, the answer is maybe, okay? Because the Nevada test site was designed to be a high-risk experimental test site. So the environmental impact statement they did wrote in a lot of high-risk kinds of stuff. So probably less. Now, I don't think it's going to be on the Nevada test site. It doesn't have to be on the Nevada test site. But you will have to sit through an environmental impact statement. And what I know about environmental impact statements, if the government wants you to do it, probably pretty easy to pass. If the government doesn't, it's probably never going to pass. So our job here is to make them want to do it. Now, if we volunteer to do this in Nevada, there's no other plan for the spent fuel. There's no other future plan. There's no other any plan. And no state has consented. So their idea now is to shop around for a consenting state. Have you felt shopped around for that? Have you heard anything about wanting to raid? No, they're talking about it in meetings and asking the public, and same thing they did in the 2012 Blue Ribbon Commission. So keeps on going down the road because why? Because people are afraid of it. And if they can keep people afraid of it, then maybe nuclear won't happen. And the gas and oil company lobbies will be real happy. They view this as competition. So part of what my job would be is to talk to those energy companies. It's not competition. It's follow-on energy. You're not fossil fuel energy companies. You're energy companies. We're going to have fossil fuels for 5 decades. Okay, we're just not going to go away by 2035 or 2050. Those people saying they'll be dead by then. So, we guessed wrong. Okay, so there's no danger in any industry over a 2-decade change. Same thing happened with UAVs. All the pilots, oh, no, never do without pilots. Oh, that's horrible, blah, blah, blah. Well, transition is going to be for 2 decades, right? See, all of you are going to have your career. All your kids are going to have their career in manned aviation. And as they transition, or which they have in the Air Force, it's like the career path now to promotion is through the UAV side, not through the fighter pilot side. Sad day for a lot of people, right, Don? Okay, but that's the transition. So you're not going to fire all the pilots right away and start flying UAVs because they're not ready. You need to develop over the time. But the next fighter jet in the military for the Navy and the Air Force is an unmanned fighter jet. We can talk about that all day if you want to, because it's fun to talk about. But the answer is the EIS is very much subjective. And I think they could make it work or not work depending on the desire. The EIS is for wind and solar work great. There's no disposition money, no decomposition money. Don't know where they're going to put all the waste. I don't know, care about the desert tortoise anymore, but EIS is approved. No, so I sound cynical about it. I'm sorry, but that's kind of suspicious to me. Who's got the microphone now? Oh, who's ever got the microphone has the power. Okay.
Casinos, wouldn't it behoove them to support the idea of nuclear power, however it gets here? Because their business absolutely relies upon power and water?
Absolutely, yes.
So are they?
Well, apparently no. And so the big impediment, no matter what they say to nuclear power right now, it's not cheap natural gas, it's not subsidized wind and solar. That's a huge impediment because the utilities are monopolies and they own all the power generation. If you pay them $100 billion to put in wind and solar, they're gonna, if you pay them $6 billion to put in nuclear, they're gonna take the $6 billion and maybe they will, maybe they won't, okay? Because it's a wide money difference. But there's no free enterprise concept to it. Okay, so it might make sense to a market. It might make sense even to a society, but we're not forcing that issue on them. We're not saying we really believe in free enterprise. So get the heck out of the business. What business do they have putting $100 billion in any sector? Okay. And I get in trouble if I say this, so I won't say it, but that happens a lot now. So the answer is yes. And it's not going to be politicians who does it. It's we, the people, that are going to do it. But mark my words, when we get the preponderance, and it's going to happen, it's a matter when, the preponderance of public sentiment for nuclear, it's already changing. All of these politicians would say, I was always for that. You watch.
Yeah,
Always in favor of that.
especially Al Gore. Mhm.
And then when we get that's fine. They can say that's okay with me as long as they do it. Okay, who's got the microphone now?
For the last 12 years, I've been opposing wind and solar
Okay,
because of the tremendous land use and destruction. And of course,
you mean opposing it?
opposing
Okay, all right.
the land, yeah, wind and solar, the way that they're doing it. Because right now there are plans for a new transmission line to run from Apex out north of town
You don't mind, I'm gonna take my coat off.
to Yerington so that there can be solar PV panels in every valley between here and there. Right now, there are applications for 230 square miles of PV panels. And of course, the utilities are all for that. NV Energy is promoting this line, which you and I, as power ratepayers, will pay for, and taxpayers.
Probably your grandkids will pay for it, but that's another
Absolutely.
story.
And right now they're starting to determine, gee, we do create some dust.
How about that?
Already here in the valley, I've lived here for 60 years. The solar in El Dorado Valley, Boulder City, out by Apex, down by Ivanpah, and now they're in the process of creating 18,000 acres of solar in Pahrump Valley. We get wind or dust storms unlike I've ever seen. And I think that you have to win the utility companies. Good luck with that. And, you know, most people who live here moved here in the last 15 years. They have no idea that the test site existed and that there were actually nuclear weapons out
They
there.
don't know anything about Yucca Mountain because nobody's talked about it in a decade. Yeah.
But good luck getting past the politicians and the utilities.
Well, so did you have a question or do you want me to comment on that?
No question. No.
Okay, well, let me comment on that then, because you opened the door and I can. So it doesn't make any sense on a practical level, and they don't talk about any of that. All they talk about is it's no cost to have sun. Okay, I live in Minnesota. They are marketing solar panels in Minnesota, okay, where the sun does not shine all that much. We're glad when it does, get me wrong. And the winter is covered with snow. Okay, so I've seen them on the freeway driving back in the winter where they're covered with a tarp for probably easily 5 months out of the year. So remember I talked about capacity factor? They brag about what the nameplate is. Oh, we have 7 megawatts of solar installed. Well, if they only produce the equivalent of 700 kilowatts over time, and then it's really tricky to get it installed into the national grid system in the right way because it produces direct current power, and we need alternate current power for the grid. And the law says you have to use this power first if it's there. So they're running around turning on and off natural gas peaker plants. And if you build a big solar panel plant, you need to build a peaker plant right next to it. So you're getting the same capacity for one capacity plant, but you got to build 2. So that's why I like the free enterprise system. This would never fly on a free enterprise system. But imagine $100 billion, not just 100 billion, hundreds of billions. They throw on trillion like it's 10 cents. And so hundreds of billions of dollars for a market that produces maybe $50 billion in revenue all over the United States. That doesn't make any business sense to anybody. So if the solar panel guys want to compete, figure out how to get it to compete. You're buying the same solar panels you did a decade ago. There's no innovation and improvement or anything in them. You're just buying the same panels, and guess where they're made? 98% of them are made in China. Guess where the companies are based that are putting them in? Mostly Netherlands and Spain. There's no companies here putting them in. And now they want offshore wind off. So you really need to, as a people, as just guys paying for this, you got to think about it. You got to think about it in a practical way and spread the word, because we, the people, are really, I think, being taken advantage of. And good point. Thanks for bringing that up. You can throw that on the floor. That's mine.
Oh, that's not mine. Yeah. As I understand it, this what you're suggesting is based on a concept that really hasn't been tried, which is to use this spent fuel and be able to create energy from it. So why aren't the existing nuclear plants doing that? Why aren't they using this fuel to do more, to get more electricity generated? And what are the prospects of working with the people in Indonesia to achieve that goal of actually creating one of these things?
This is my favorite question. So here we go. Thank you for that question. First of all, it's an American company that's in Indonesia. That's because they'll have lower standards for them for the safest production of energy, because their people need the energy. So they'll be able to open a plant over there and crank these out like Ford Model A's and put them all over Indonesia. They could certainly do that here if the regulatory system was in place to do it. So remember, the safest power. Okay, so we talked about all the accidents, why we didn't talk about them. I did that purposely. Okay. So if you wanted to ask questions about it, you could, but the reason for safety, for mechanical safety features on any machine or any operation, is to protect people, right? It's not to stop accidents. We do safety procedures for people to stop accidents, but people are people, gonna have accidents. 3 Mile Island, nobody hurt. Fukushima, nobody hurt. Chernobyl, about 35 people hurt, okay, and killed, but no long-lasting effects, despite what they tell you, okay? And the people who ran that reactor at the time it blew up defeated every safety feature on there. They purposely shut down every safety feature that reactor had, one of which was not an intercontainment vessel, okay? So they tout Chernobyl as if it was an operating reactor that blew up, just a regular operating reactor running its normal operations that blew up. It was all those safety features were defeated on purpose to run an experiment. If you watch the HBO special, ignore all the radiation parts of it, but they explained the process of the accident pretty well. And 3 reactors of that same design, 3 reactors of the same design ran for 14 years right next door to them. There's a 4-reactor cascade there for 14 years because they couldn't replace the energy with anything else for that long a period of time. No problem. No safety issues, no nothing with those reactors. They're not running today. That reactor design is no longer valid. And I showed you the pressure vessel that they put ours into, okay? It's not going to be, even if it melts down, it's not going to be defeated, okay? And then there's inner and outer containment. There's even now from Fukushima, there's a bottom part where it can go to and sit if it makes it through the inner containment vessel. So that meltdown is not going to hurt anybody. It's a tremendously expensive accident, and it shouldn't ever happen. And it's only happened once in the commercial operation of the U.S. fleet, but nobody got hurt.
I'm not talking about the safety. I'm talking about why don't you be happy with what's happening in it?
Okay, the second, yep. Second part is, why aren't we doing this now? And your guess is as good as mine, because I've been tirelessly advocating this for decades, okay? And it has to do with what I call rice bowls, in my opinion. I call it rice bowls. Somebody's got a profit center that they really want to exploit. They want to keep that thing going. And they don't want anybody to mess that up. Well, guess what free enterprise does? it blows that stuff apart, disrupts it, okay? Because a guy has a better idea, he's going to come in and compete with you, and you guys all benefit from that because you get the result of you get to choose which of the things that are beneficial to you, and they got to guess what's beneficial to you, and if they guess wrong, they're out of business. But that doesn't happen with a monopoly. They can run things any way they want. They have some kind of a commission here that tells you what rates you're going to pay, and if Nevada Energy wants to charge more rates because they messed up and made a mistake and had huge expenses, well, guess what? You're going to pay for it. So there's no incentive for them to be efficient. In fact, that's one of the problems with the whole system is when they fix the grid, they base their rates on how much you spend and expense. So if you're fixing the grid, they're going to want all the best stuff on there. They're going to replace it every year. They're going to put new wires up and everything. So it should be running like a top, because they want to spend all the money on it now to fix it. Well, they changed that system and now nobody really is responsible for the grid. Okay, so it's not being kept the way it should be in a lot of cases. So the answer to your question is it's not a free enterprise system. It's not a. Well, it's an American company.
Why they have trouble doing building?
No, they're going great guns in Indonesia.
So why don't we?
Well, I'm sure Indonesia's happy about it. I'm not happy because they're not over marketing them over here. I'm sure Indonesia's plenty happy about it. They wouldn't be over there. So they're marketing all their reactors over in Indonesia when they should be marketing here. Okay. Yes, they have. Yeah, they're building them now and designing them, and they're running it through the Indonesia regulatory system, but it's not as onerous as ours is because guess what? They want them to come in.
Are they actually functioning?
Yeah, there's functioning reactors over there. They're not commercially viable yet, but they're functioning. Well, you got to go through the whole prototype system. You got to build the reactor and test it out, and you got to prove that it's safe, and you got to go through all those hoops to get a reactor on the site. But once you get the first of a kind commercial reactor in and approved, then you can open a factory and build hundreds of them for a very cheap price. So they're working on it over there, but they're not here working on it. That's my point. You understand?
Yeah, I understand.
Okay. So they're a fully capitalized, investor-based private company that's marketing their product the best they can. And they decided that not here is the place to market it, but Indonesia is the place to market it. That's sad to me. Okay. That's really a step backwards we invented this technology. We showed the world how to use it, like the transistor. You remember the transistor? We invented the transistor here.
But that's happening with everything.
Maybe it'll come back.
China's out doing this in every.
Yep. Maybe we'll learn our lesson as we did with the transistor. Because what Japanese bought all the transistor made radios out of them and sold the crap out of them, right? But when we wanted fast computers, came back to here, we absolutely blew the rest of the world away with integrated circuits, which are transistors, and brought the business back here for the high-speed computers. Maybe we'll do this with reactors, and I hope we will. But why do we go through that process of not doing it in the first place? Is my question. And so, does that answer your question?
Invest in this company in Indonesia?
Did I invest?
Can we?
Sure, you can. Thorcon is the name of the company. You go buy stock in Thorcon if you want. Sure. Thorcon's the name of the company. You can go on their website and see everything you want about what their technology is and what they're doing. And but they're a private company capitalized with investors and trying to make a profit. So yeah, look it up. Yep. So
try and formulate this in a question, not like a angry rant, but like the
Ken, if you want, that's okay.
like we're finally getting to it at the end, but the issue that we have not just in Nevada, but most of the US is the government set up monopolies with the utilities, and the utilities seem to be where all of our problems are for getting to reactors before we even get to the nuclear fuel usage or transportation or all of that, where they are set up to act as monopolies and they have no incentive to reduce costs. And from like Warren Buffett's standpoint, owning NV Energy and everything else, including like the mines that are getting all the fuel and all of that, so they have the whole means of production for energy, and they have no incentive to spend $6 billion on a new technology or plant for a alternative when they could spend $100 billion to build like a giant solar farm, because they are guaranteed returns of like 10% on that, and they can just shoehorn the approval in. So it's like needing to start the solution at like dissolving those monopolies and giving way for like actual free market, or like in my opinion, it should be like, there's arguments to be said if it's like a state-run like public utility, like there's many public utilities that are much better than the like corporate energy providers. And in my opinion, it should be like a large government run thing or nonprofit run thing where the incentive is to reduce the cost of energy as much as possible to the end consumer. So I do work in the solar industry and on the consumer distributed generation side.
Okay.
Because I want to be like independent from like the forced utility and control what my costs of power are, because I want to get those as cheap as possible so I can have the like endless free energy. And it's like, shouldn't we instead focus our energies on fighting the monopolies that have this like endless control over all of the end consumers, instead of like they have us bickering back and forth between nuclear and other renewables as like who's more incentivized or what's better? And
So you're talking in circles, okay?
Yeah.
You're saying a
But-
government monopoly is okay, but a private monopoly is not. And I
no,
radically disagree with you on that.
I'm saying their incentives are different. So if one is for the end consumer to have the lowest cost of power, that's going to be completely opposite versus NV Energy and Warren Buffett of wanting to make a fixed return on their investment. And so,
Okay, so what if the Warren Buffett monopoly is in cahoots with the government supply monopoly? Okay,
yeah, that's the
what
problem
happens
right now.
then? I can tell you what that's called,
They just
but
keep
you won't
going up.
like it. Okay, it's called National Socialism. Okay, we tried that experiment several times in history, and it just didn't work. Okay, so what my opinion? Okay, and I'm a free enterprise kind of constitutional believer guy. Okay, that the best deal for the consumer is competition. Okay, so the government's job is to ensure that there's a level playing field for competition. When the government gets into the business of selecting winners in the business, you get corporate, rich people monopolies in cahoots with government monopolies, power systems. And like I said, that's called National Socialism. And you got to really slow that down, in my opinion. I think it's best to level the play. The government has no business providing subsidies for anything. Okay, in my opinion.
Agreed.
They have to have laws and rules. If they want to have clean energy subsidies, then they say if any power source that produces less than 50 grams per kilowatt hour in carbon, which I personally don't believe is a danger, but pollution is, then every power system that produces that should get that incentive. Okay.
Yeah.
Not we're going to pay hundreds of billions of dollars for wind and solar subsidies and nothing for nuclear. And we're going to make the requirement to get into the nuclear game really high regulatorily and make it easy for wind and solar. Okay. Because that's great if wind and solar works. But what happens when the monopoly for wind and solar comes in and there's no other option for you? Okay. Then the wind and solar owners all of a sudden become the next monopoly generators. And you're a young generation. You're the ones going to have to pick the pieces from this. And so I'm telling you, if you look at history and look at how things have gone, that doesn't work.
Yeah, and I'm saying that's the situation we're in now, where there's these government granted monopolies to power generation, and they have no incentive to reduce like the cost of energy to the end consumer. Their incentive is to spend as much money as possible because they are guaranteed returns on those investments.
Yep.
And so we need to start with like removing that problem so that we can invest in the like small reactors.
And
that,
so what's your plan for removing that problem?
saying like the legislation side should like, we should have our energy focused on like fixing that, and not just like having the governor say bring in like nuclear fuel, because that nuclear fuel is just going to go straight to NV Energy, and then they're going to be like, oh well, let's say
No, not if you keep it in the private sector. Okay.
But the
No, and Nevada Energy is not going to like this idea at all. Okay. But are you in the business of making Nevada Energy happy?
no,
Or are you in the business of
can't
making the people of Nevada happy? That's the question you have to ask yourself.
I'm saying make
especially
people
in
of
Nevada.
happy and have our
Right.
cost of power a lot cheaper.
Right. So well, you want to generate a competitive nature with the business of energy generation. If you go to Nevada Energy and ask them that, they'll say that's impossible.
Yeah, but
We have to have a monopoly to have a generation of energy system. I contend that you do not, because we've seen how the AT&T system could be decentralized, and that was
Yeah.
hugely beneficial.
Yeah.
Because you're not old enough to know that you got your ass kicked for making a long distance phone call
No.
when you were a kid. You grew up in a system where you could always make a long distance phone call, no problem. So that really was a benefit to the consumer. Okay, energy system needs to look like that, and how you distribute the energy has to be innovative, has to be clever, because
Yeah, but
the
that's
biggest
getting into a
expense that
different
the utilities
argument.
should be worried about is that grid, because if the grid doesn't work, they have no way to deliver their product. But they're not worried about that. Why? Because they're in bed with the government side of it, who's going to take care of if they don't. How can that be beneficial to the consumer?
Yeah, but you're saying like bring fuel in like from the government to the test site.
Yeah.
But that's purely generation. But then since NV Energy still has the monopoly on the distribution system, like that's a different problem altogether. Like that,
It is a big problem. But if the governor says that it's okay, he consents to do this, he's probably aware of that problem. So if he decides that, if you suddenly have a really good governor that decides to come in and do that, he's probably decided that Nevada energy monopoly is not the way to go. Okay, so why do we have a Nevada energy monopoly if it's not good for the people? What could the other possible answer be? That monopolies are good for somebody else besides the people.
Yeah.
Yes.
There's another solution. The PUC,
Mhm.
besides the rates of
Mhm.
the electric company.
Mhm.
And so if they were able to get electricity much cheaper from this system
Mhm.
than from the solar, they would be required to do that.
You think so?
Be required to do that.
But don't you think the PUC is sort of a government entity?
It is, right, but.
Don't you think they're a little possible to be corrupted on the side of the government entity to favor a business or another? No? I may be off on this. I'm sorry, but I've lived 68 years almost, and I haven't seen any system where it's not like that.
Well, if you look at the electric rates and compare them with the water rates, water rates have gone up much faster than our electric rates. We're virtually at what, 13 cents, 12 cents.
Well, maybe we should compete water then.
What?
Maybe we should compete the water market. You have water, you have lots and lots of different water companies who have clever ways to get water. Maybe they'll use reactors to get desalination plants, sell water at half price. And then you buy it from them. You don't buy it from the 13-cent people.
Yeah.
That's how innovation works. Government doesn't do innovation. Private business in competition does innovation.
So I think we're going to
Yes.
move on to the next question.
Okay. Hold on. He's got the microphone. I'll get back to you in a minute. Okay, go ahead.
I'll hand it to you here in just a second. Steve, really quick, what are our next steps to move this thing forward?
If you want to do this, and this is my opinion, I'm not an entrepreneur. Okay. So this is a strange kind of I'm not in business to make a whole bunch of money kind of approach. But my thought is that we need a program office to socialize this somehow to a governor. Okay. And get to a governor is something I can't do. So I'll need somebody with some stroke to present this to the governor. But I can tell you that everybody I present this to loves the idea of recycling spent fuel instead of buried in a mountain, and it might leak for years and all that stuff. Okay, that's really attractive to almost all the public. All right. So if I could attract a governor, and I'm not saying a Nevada governor is the one, I'd be glad to brief him on this. And we were going to brief the Nevada Projects Office on this before COVID came and they closed everything down. So now the Halstead's gone and Richard Bryan's gone, and they got a whole new office, and I don't know how to get an audience with those people. But if I had some rich entrepreneur wanting to try to purvey this business, I'll bet I could get to the governor because they listen to money. So that's my idea, is to get somebody who is attracted to this business plan that I can work with to to move it along forward. So I need about a $10 million 2-year program office, and I will not do a government program office. It will have to be a privately funded office, or I'll go somewhere else and do it. Huh? Yeah. So I mean, because I've had hard experience in the other direction. So this is what I'm trying to generate. Okay, all right. So this is what I'm trying to generate the idea of, okay? So if I got a guy that said, you know what? Really like the idea. I like what you're doing. So here, we're going to start your program office. What do we do? I say, you go out and talk to the American Nuclear Society, Professional Society. You talk to the environmental groups because they love nuclear. They just don't understand it. Nobody's talking to them. You go out and talk to the energy groups, the American Petroleum Industry, the fossil fuels, and tell them nuclear is not your competition. Nuclear is the follow-on energy. So you're not a fossil fuel company, you're an energy company. So maybe you ought to consider embracing this as a future generation of energy over the 2 generations that you're going to transition this, because you're not going to shut down coal and all a natural gas fired power plant, you're just not. And so then you get the group of people to start to liken this and whispering it around, spreading it around. And then kind of the governor has to hear this if he starts getting the jazz of it. That's the only way I know how to do it. But I don't want to be the one that starts the company and do all that. I want somebody else to have the money. But if for $10 million investment, you can see $100 billion revenue, it's a lot better than $100 billion revenue chasing a $50 billion, $100 billion investment chasing a $50 billion revenue. That's, to me, is much better. So, like I said, I told you up front, I'm a constitutional believer and I'm a free enterprise guy. And I understand the value of having government do stuff, but I also worked for the government, okay? So it's a nice idea, but it doesn't work. And when I was in the Army, they told me, if it's a good idea, but it doesn't work, it's not a good idea. And so I believe that. So the point is, I'd love to talk to you about this, how it could work, but you're presupposing that people in the government have this benevolent issue to make everything work for people. And I haven't seen that lately. So the way you can for sure trust it is have a levelized playing field for free enterprise and let everybody compete for the business. Because if these people over here have a crappy idea, nuclear is too expensive. Nuclear is too expensive, nobody's going to buy it. So wind and solar is the way to go, and they can make it inexpensive and market it to people. That's the way people will go. Okay. But environmentalists are fighting this all over the country. They want to cut 4,000 acres of trees in Virginia to put solar panels up. People went through the roof. Okay. And blatantly, outlandishly, total use of land. I think it's 10 acres for a kilowatt, or 10 acres for a megawatt of solar power. So pencil that out with reactors, land for land on how much power they can generate. And you get numbers 100, 150, 160 times the land requirement. And so, again, my interest in this is to make things better for people. And I know that if you can have unlimited energy, very, very cheap for people, they can indeed be free, okay? The people in Africa can be free. The people in all over the world that are poverty stricken can be free because they can have all the tools everybody else has because it's almost free to have electricity. Well, they don't have that now. And there's a lot of people who want to make a lot of money because you guys want electric energy. Okay. I get it. It's nice to have a lot of money. But in our country, I thought anyway, that the consumer ruled the roost, that we, the people, ran the country. That's what I was raised to know. So this is the kind of process we're trying to move towards, I think. Dave? Oh, I'm sorry. You have the microphone. You have the power.
Hi.
Hi.
It's good to see you again.
Well, thank you for coming back. Hi, Xander. How you doing? Good.
And this is his little brother, Maddox.
Hi, Maddox.
You say
You gonna be a
hi?
nuclear physicist too?
Probably not.
Okay, all right.
So
Pro ball player?
I don't know. Maybe karate, right?
Karate, yes.
Yeah.
All right.
So yeah, we brought the whole family because
I like
Xander
it.
and that's my Paul.
Oh, we got you the VIP seats. I hope you appreciate that.
We're good. We got to take a nap. So, Xander and I were really impressed by your talk on Wednesday. And so he wanted to come back again today.
Okay, great.
And it got me thinking about how we sell this. right?
Okay.
You have to sell it so that
Definitely
a
have
whole
some.
bunch of people aren't like stomping their feet saying this is bad. And I'm wondering if there's been any studies commissioned about what would be the economic benefits towards having this here. Because in my mind, if we're the only state doing it, taking on nuclear waste because they don't know what to do with it right now, it could like far surpass the gaming industry. I mean, I mean, I'm just thinking like this could be massive on economic benefits, jobs, tax revenue,
High
and
tech.
so on and so. Yeah, exactly. High tech.
University.
Yes, exactly. Education, which is something that we struggle with as well. So I don't know, my mind's gone to some, fantastic places and hopes for this. So that's my question
Well,
is, have
thanks
you
for the
guys look
question.
into that?
You guys did I set you up these questions? This is great. So there's two of us in this entire country talking about this, okay? My buddy in Virginia and me. And we're cutting through a lot of old time thinking and old ways of doing things and all that stuff. So that's the thing that has to be overcome. So I can do the technical side of this. I can talk to you all day about how this can be beneficial. And I can even tell you how the money side works, but I can't tell you how the political side works. As far as I know, people control the political side.
Yeah.
So I'm going to the people. If I can get an audience with the governor, I'm going to take one. But so far, none of them want to hear about this.
You're not going to get one with this governor.
Well, we could get another governor, but we won't talk about that.
I'm crossing my fingers.
But there's other states, okay? There's other states that could hear this and eventually like it. But me talking from, the world's poorest philanthropist is as effective as somebody coming in with an investment in a company and a business plan that could say, hey, guys, I have the firepower to do this. What do you think? And how you control the political side of that is everybody knows how that works.
Have you reached out to MPRI?
No, but I'll be glad to talk to them.
Yeah, we should.
Anybody, as everybody tells me that Elon Musk would love this, you should go talk to Elon Musk. And I go, he was over for lunch and I forgot to mention it the other day. Well, he likes anything that makes money. Okay. And so, but that's great. Give me an appointment. Okay. I'll talk to him anytime.
I'll take this in a little bit of a different direction.
Thank you.
I used to work for the dreaded Hyman Rickover.
One of
Mr.
my
Mueller
favorite
when
guys.
I was in a nuclear Navy.
Yep.
Nuclear submarines. And we remove fuel when we refuel our ships or defuel them. Put them in our M130 containers or M160s.
Just 1 second.
Yeah.
Sandra, could you give me water, please? Thank you. Go ahead.
Put it on a ship. And the joke was they're going to send it up to the place I live now in Nevada.
Thank you.
So, we thought that was pretty funny back then. I don't
Okay.
think it's funny anymore. But it intrigues me when I read the email that your intentions or the intentions of this is to reuse spent fuel because we just shipped them out. We didn't really care about where they were going.
Tell everybody what the difference between the Navy nuclear fuel and the commercial reactor fuel is.
I've never seen the private plants, but I know what the Navy one looks like.
What fuel? What's the fuel composition for Navy fuel? I just told you what the commercial was.
Yeah.
4% enriched.
Okay.
What's the Navy fuel?
It was uranium-235. And I if I remember correctly, there were beryllium.
Yep.
And
It's 95%
cladded.
enriched. Okay.
And they were
That's-
cladded.
That's a real easy reactor to make it work.
Yeah.
But what's the downside of having highly enriched uranium in a reactor?
When it starts up, when it's time to remove that, all the work that you got to do,
Yeah.
people in suits.
What they're worried about
containers.
is somebody stealing that material and making a bomb.
Oh, yeah.
Okay, it's highly enriched uranium can make a bomb.
Yeah.
So they're not going to let commercial reactors have highly enriched uranium.
Okay.
But the highly enriched uranium reactors, how long do they run in the submarine?
Well, we had talked
30
about
years.
20 years. or
They
so.
ran 30 years. How long does a submarine last? 30 years. So you have a machine that does never, ever need to be refueled.
Right.
That's 100% quiet in its operation. Okay.
And
So that's-
you were right about it can stay under really long. I mean, it doesn't need anything. Like you
Just
said,
has to keep the people
food,
happy, and they're in the Navy, so they're
reprocess their
happy
water
when they're told they're happy.
and the fuel. Yeah, in fact, you know, it was personnel that were having problems being under that
Yep.
long.
Yep, they want to go up to Singapore and get some lettuce every
Right,
once in a while.
right. But the thing that intrigued me about this was that we're talking about reusing fuel that's sitting around doing nothing but giving off radiation. But your idea is to reuse them until they're really spent, until they're really used up. And the other part was the water. It sounds like there's little water or no water needed, unlike regular, like Fukushima. When Fukushima went down, we sent our REACT team, radiological emergency
You with
accident
RSL?
team. Yeah, so our people came back contaminated.
They were my people at one time,
Yeah.
but now they're your people.
Yeah. But yeah, they would need water, but I like the fact that these plants might need just a minimum of water.
Yep.
And
Some of them don't need any water, just
Yeah.
sodium cooled or salt cooled. There's no, well, unless you're driving a turbine, then you need the water for the steam. But
Right.
the water they use in fast water reactors, almost none of it is used to generate the steam. The vast majority of it you use to keep 2/3 that they don't use cool. Okay.
okay, so then I have a steam generator that
They do.
transfers the hot water. And
They do, but
steam.
when you see the ocean flowing through the reactor, most of that's not water to turn into steam. Most of that's water taking heat away. That's not used to
Right.
produce steam, just to keep able to run the 50 million to 1 heat release.
Right.
That's a lot of heat removal. So that's why you need oceans of water flowing
they
through
got
it.
that regenerative, non-regenerative heat exchangers.
Mhm.
Good.
Well, thanks for bringing up the nuclear Navy, because that's Rickover was a bulldog and everybody hated him,
was.
but he got through all the government red tape.
But he also
got
kept
it
us
done.
in line. A lot of people would like to take shortcuts. He would breathe down our necks so that we would breathe down their necks.
That's right.
So
How long was he in the Navy?
he was gone, I think, by the time, but the stories were still around. I went in
They had
79.
to negotiate with him to get to retire. As at least 45 years. He hung around the offices of DOE and they finally had to assign somebody to go figure out how to get him to retire.
His ghost is still around at Pearl Harbor
I know.
and all the nuclear.
He's my hero. I'll tell you, he's a real hero to me, but I don't think I could work for him.
Yeah.
But thanks for that. That's a good perspective. And those spent fuel from the Navy reactors over this 6 decades are sitting in Idaho in a pit, and they're still highly enriched uranium. There's 39 tons of plutonium sitting at Pantex, weapons grade plutonium that they dearly like to get rid of, but they can't just flush it down the toilet. A reactor would burn that all off. And so there's lots of reasons to do this technically, but for some reason they're not. And so that's what I have to get you guys to help me figure. He's got the microphone. I'll get to you next. Okay.
Yeah, I'm sorry, Steve. I'm going to try and answer a question that has come to you
Okay.
from this gentleman, from Tom,
Okay.
about this process. When you need to start it, and I can say this, in the right political climate, not just in the right state political climate, but the federal political climate.
Mhm.
I lived through this in Illinois. I served on an impact statement committee for a nuclear power plant in Clinton, Illinois. You might be familiar with that. They took the design from Dresden nuclear power plant, which had been operating outside of Chicago for years. They were building 2 750 megawatt.
Okay, before you go any farther, tell them who has the most nuclear power commercial reactors in the country, which state?
Probably Illinois.
Illinois. Okay, go ahead. I'm sorry.
I've been out here for years, so I'm not sure anymore. But I watched this nuclear power plant being built. 2 750 megawatt units at a cost of $650 million. the political climate changed in 1976. We went from 2 units to 1. We went from a cost of $650 million to $1.3 billion. And the Nuclear Regulatory Commission sent us guideline changes at a rate of 10 changes per day. Our Environmental Impact Statement Committee had to review all these and say yes or no to the Illinois General Assembly, to Illinois Power, who was building this. And to give you an idea, less than 1% of these changes had anything to do with safety. Safety was not the concern of these people. The fact that they could build it a little bit differently or this or that is the only thing they worried about. And it was money in their pockets. From 650 million to 1.3 billion, and less than half of what they were going to build.
So why are there overruns?
Yeah.
I can't, it's hard to figure out.
Yeah. Political climate is
Well, here's my idea. Here's my answer to political climate. And I've thought about this long and hard. Everybody that's working this is trying to work it through the federal government. My experience is the federal government is lame on this and not the place to go. But imagine if they've had a problem for 40 years, they spent $15 billion for, and they can't solve it even now. Okay. What if a governor comes to them and says, I can solve your problem. This is how we're going to solve your problem. I will agree to consent to accept your used nuclear fuel so that you have this solution now that you've spent they've spent a lot more than that, but at least $15 billion in 40 years on. They can't say no. The political climate would be that they can't say no. Now, if they say, when they say yes, okay, it changes the entire face of the nuclear business in the entire country overnight. Because what's Nevada know that nobody else knows? What's North Dakota know that nobody else knows? What the heck is going on, right? And where can I get in on this? Where can I get my 40 billion, right? So those are the things that generate through their minds. And so all of a sudden now, Alaska Pipeline is a perfect example. Okay. Oh no, we're not going to Alaska Pipeline up here. Nothing doing, man. This is environmentally sound and safe and everything. We can give you guys $1,000 a year. Oh, well, if you put it up high and paint it white and, maybe that's the elk run underneath it, everything, and maybe it's okay. That's just human nature. That's the way they are. They don't know this is worth 100 trillion. You guys are the only ones who know it's worth 100 trillion. Okay. But if a governor could be convinced, he could easily convince the feds because everything would change if one governor would say that. But they're not. Texas, 328 to like 15 to not allow an interim repository in their state until they find a final solution. New Mexico, legal stops, everything. You're not going to do it. And yet they spend billions on the design. Companies are making billions of dollars designing this damn thing. And they're not, and Texas and Mexico, no, not only no, but so they spent more money on a thing that the states say no. And yet they go, well, we got to find a way to get states to consent. So let's talk about this. Let's have a commission. Let's have some more meetings and talk about it. I worked for the DOE. There's no incentive to have a solution, an innovative solution. Okay. That's the problem. So if we get it back in the hands of the private enterprise, like it was before 1976, when they were solving the problem, okay, get it back in the hands of the private industry, I think it would move very quickly and be solved. But I mean, there's a huge profit incentive to this one now. So that was my approach. I'm not even talking to the feds because I don't think it's worth we did talk to the Assistant Secretary of Nuclear Energy, Rita Barinwald, when she was there. We went and briefed her, and she said, "So what's your ask?" I said, "I'm not having an ask. I just want to let you know what we're busy doing. Maybe you could help us." So in her mind, everybody comes to her and asks her for something. I want $1 billion. I want $100 million. How you come and say, "We don't have an ask. We just let you know we want to know if you could, help out move this down the road." Well, thanks. Go away, kid. You bother me. And so we walked out of the room. And they said, maybe we should have had an ask. Yeah, 10 million.
So unfortunately, that's going to be the last question that we have
No.
during the event, but Mr. Curtis will be available to talk to you after. I just wanted to go up and thank you.
Joe,
Mr.
thank you
Curtis,
very
again.
much for letting me do this, man. I'll tell you.
Absolutely, my pleasure.
Yeah.
Thank you.
We'll be proceeding.
Always
I'm
a
sure.
pleasure to have you here at the museum. So,
Thank you.
and thank you everyone for taking time out of your afternoon to join us. And like I said, Mr. Curtis will be available afterwards for a little meet and greet. So I'd be happy to answer your questions. But again, Mr.
can have
Curtis,
this
always
back.
a pleasure. Thank you all so much for coming today.
Here, I'm gonna take that off.
Yeah. All right, awesome.
I want this back.
Perfect.
Think so.
Yeah, absolutely. Yeah, I figured this way, like